welcome to the first episode of the Idealized Science podcast. I'm your co-host, Jacob Becky. I'm a theoretical physics PhD student at University of Colorado Boulder, and I'm set to graduate this May, and I'm an aspiring science educator. And in this podcast, I'll be conversing with Dr. Brian M. Wargo, and maybe for this first episode, if you could introduce yourself, Wargo, and tell the listeners a little bit about yourself.
Sure. Undergrad, I went to West Virginia University and studied biology, physics, and general science for teaching. And then I went to graduate school where I studied physics and specialized in X-ray crystallography. And then I went to the University of Pittsburgh for a PhD in science education, instruction and learning, and spent an awful lot of time there doing some educational research. So hopefully that gives a little background.
Yeah, absolutely. Thank you. And so Dr. Wargo and I go, way back. I had him in high school when I was, what age would I have been? Maybe 15 at the time, 16, when I first took Physics 1 with Dr. Wargo. And I immediately knew that, something was different in the classroom. I had never had a course structured this way. And, I've since come to learn how much education research went into the creation of the course. And how much expertise developed over years went into the successful execution of that research. So as I graduated from Freedom, I went on to study physics and math at Clarion University of Pennsylvania, a small state school not far from Pittsburgh. And I then went on to do a master's at the University of Birmingham in translational quantum technology before starting my PhD here at University of Colorado Boulder, where I'm set to graduate in May. And a few years ago, Dr. Wargo and I finally decided that we would, like to help other teachers outside of just helping students. We'd like to help other teachers access, science education research and implement the practices in the classroom, as well as just try to contribute to an ongoing positive change in science education. And that's where the Idealized Science Institute comes in, which we co-founded over a year ago now. And the podcast here is designed to hopefully selfishly help me learn more science education research, more physics education research as I go through the process of applying to tenure track positions in the coming years. And along the way, we hope that we can help contextualize and break down articles for people that are interested. So that could be science educators, that could be aspiring teachers that are, students still, and that could also be for anyone that's just interested in learning the ins and outs of science and science education. So Wargo, if you want to add anything there, and then if not, we can jump into the first episode.
We really hope this will be useful. A lot of these educational articles are real gems, but a lot of people don't have time to read through them, and they might not have access to them. And hopefully we can enlighten everyone, students, teachers, other educators, other researchers, physics people, science people, about what the state of the research is. So that's our goal.
Yeah, absolutely. And like I said, I'm not an expert in science education, but I am very passionate about it. And I hope that, my questioning, even if naive at times, will be more in line with the listeners, and Dr. Wargo's expertise will be very valuable, both providing the actual data when necessary, as well as the context, both historical and present. And together we hope to provide a service for people interested in science education. So thanks very much for listening to the first episode. And without further ado, we'll get into the Idealized Science podcast. Right, in this episode of the Idealized Science podcast, we'll be discussing the past and future of physics education reform. This is a Physics Today article from 2017 by Valerie Otero, a professor of science education at the University of Colorado Boulder, and David Meltzer, an associate professor in the College of Integrative Sciences and Arts at Arizona State University in Mesa. So this article is sort of in response to legislation passed during the Obama administration, the Every Student Succeeds Act, which was passed in 2015. And although that's the sort of starting point of the article, they jump in quickly to what led up to this piece of legislation. They talk about the teacher preparation problem in physics dating back to the late 1800s through to today. This is not a new problem, as you'll find when you read this or listen to us discuss it. They talk about unanswered calls for reform and how it blends with the history of physics education research, some recurring obstacles, things that stand in the way of this well-intentioned change that has been promoted by certain science educators over the past decades. And finally, coming back to the Every Student Succeeds Act, they talk about leveraging the law for positive change in physics education research. It's really a great article. It's freely available. We'll link it in the description. And it does a great job of pointing out some of the issues with the past and some of the roadblocks for the future of physics education reform. As our podcast is focused a lot on trying to make positive change in science education, this is, we thought, a great place to start. And Wargo, maybe you could comment just a little bit from your experience of nearly 30 years of teaching on what you've seen with various standards coming out and, maybe not the adoption you would hope for in the classrooms.
Yeah, no matter where you start with your journey in looking at reform, there's always a history. And when you look at that history, you start to recognize it looks a lot like the history before and what we're doing now. So it's a journey. You just jump in, and hopefully we'll be able to provide some context about what were the goals? Have we achieved them? What are our new goals? Are we going to achieve those? So hopefully we can shine a little light on this.
And yeah, absolutely. And with that, let's just jump into the conversation. So I mean, jumping in, the article starts out, really the framing is that there's this Every Student Succeeds Act signed by Barack Obama in 2015, and its goal was to sort of fix some of the shortcomings of No Child Left Behind, which was a Bush era piece of legislation. And, that legislative side is one half of it, but the other half is just the simple fact that since the early 1900s, even late 1800s, as the article points out, we've been trying to reform physics education, and yet you look at a classroom and you largely see monologic lectures from some expert at the front and some receptacles of information in their seats, and that's what you see. So in your experience, I guess, maybe it would be helpful to give a little context about what your classroom looks like, and then what you have seen largely in your experience through the No Child Left Behind Act and then through to today.
This whole notion that we're going to fix education is kind of funny when you think about it, because we've been trying it for 150 years and we really just keep cycling back through. You talked about the No Child Left Behind Act as if it was the thing that we're now fixing. No Child Left Behind was fixing acts before it, and you could just trace those down the line. So it's the same old, same old. We've been trying for a long time to change from just having teachers simply do this didactic instruction, just lecturing at students, talking at students. And you would think after 100 years we would have a really solid way of doing this, but go into classrooms today, often it might look a little different. There might be a video monitor and the teacher is speaking at the student in that way, but much of it's the same. If you were to go back 100 years ago, 150 years ago, it looks a lot the same. So some of it's changed, but it swings back and forth. So
the article gives some potential reasons for this, but maybe before we jump in fully to their proposed justifications for, or not justifications, but proposed reasons for why there is so much inertia here. What are your initial thoughts on this? Like, to me, it seems like, okay, so to give context, as a PhD student at University of Colorado, I've had the good fortune the opportunity to teach a few times. You've taught for 30 years, essentially nonstop. So, we do offer these two different perspectives, and at the university level, at least, what I've experienced is, it is really hard, and it takes an incredible amount of prep time to create a new course from the ground up. So at least what I see in my limited experience is, the path of least resistance is to use old notes, use old slides, use old tutorials from previous years, and just put my own spin on it. That, and I'm not saying that's what I did or that's what I would want to do, but I see that that is the path of least resistance for a lot of educators. So at least right there, I see that, just year to year, that it's going to be hard to make a drastic change. So in your view, why is it so hard to encourage, if we know that the data say active engagement is better than just this didactic lecturing, what do you view as maybe the few number one barriers to change in physics education?
It's kind of like however you were taught, you're going to teach. I mean, this is natural. Like, how did you learn about education? How did you learn about physics? And let's just put a little asterisk here and say that let's keep in mind that especially physics, it's hard. All science is hard. It is difficult. Teaching, everyone thinks they can teach. Teaching well, that's really hard. I mean, it just is. And so
Right.
what you're finding right away is it's just not enough to use your lecture notes. I mean, you can get through a class. There's two different ways of thinking about this. It's teaching the lesson, like, oh, I'm going to teach this thing. I'm going to get through my notes. And the other one is this experiential piece that you're kind of interacting with others in a way that you're creating knowledge together. Now, of course, as a teacher, you know where you're going and where you want the students to go. But that feeling where they're with you and to them, they're like, oh, I just discovered this. I figured this out. That's, nearly magician level right there. But it takes a lot of work. And think of a magician. A magician doesn't pick up a deck of cards and say, oh, look what I did in front of you. No, they practice and they put an awful lot of time. And even just having the skill and the dexterity is not enough. You're putting on, this interactive program with your audience. And you're hoping that audience is with
Right.
you and they are feeling like they're part of it. So, teaching well is very hard and it's very time consuming. And it's also really rewarding, not only for the students, but for the teacher.
Right. No, I totally agree. And I think building off that, I guess, a more succinct way of saying why is reform so difficult? Well, teaching at all is very difficult. Teaching well is like a full-time job on top of everything else. So you couple that with these R1 institutions, these research-based institutions where everyone is, worried about the next grant cycle, or they're worried about the publications, the upcoming conferences, and just the functioning of their research group. It's really asking an incredible amount of these people to also teach really well. So I feel like, let's jump in and see what Otero and Meltzer have to say, but like this sort of gives some framing of how we're thinking about it. Right away, they jump in and talk about the major impediment being a lack of effectively prepared physics teachers. So the statistic they give later, and this is a stat that at least I know the American Institute of Physics, AIP, has data on it. As of 2014, about a third of physics teachers had either a bachelor's in physics or a bachelor's in physics education, meaning 2/3 do not, right? So not only is this not physicists that have hopefully authentic experiences in science, not only is it not physicists teaching our students at the secondary level, it's also not physics majors and it's not physics education majors. And so, who is teaching our students?
Well, here, let me ask you a question. How long have you been studying physics? If you're the fourth year, so you're like 7-8 years in, right? How qualified do you feel teaching classes? I mean,
I know,
right?
it's terrifying. 9 years. So before I took your class, I started on edX. Back in the day, 2013, so nearly 10 years ago, just trying to put together some stuff and start to learn some mechanics. And so 10 years in, and I feel like at every instant, I am going to say something that a student is going to be like, yeah, that's
Right.
not true. Or, I'm just going to make a blatant error. Yeah.
And you've been studying
a decade
very
in.
hard during this time, very, very hard, all these years, to become masterful at this. I mean, I'm 30 years in, and I still am always thinking about how to improve. And I think that's really part of the problem, is that we expect young teachers, let's say, and as this article details, that many of these teachers are coming out with very little physics knowledge and maybe even education knowledge, and they're expected to be good. It's the only profession where you're expected to be good on day one, and it's impossible. To become a really good teacher takes a long time. Now, that doesn't mean you can't be a competent teacher right away, but to really be good. So let's just be clear that this is like a craft that you're building continuously. Of course, you can follow other types of lessons that will help you more efficiently get through your lessons, but that's not really what we're talking about. We're not just talking about getting through a course. We are talking about, that vibe that you feel when you're resonating with that new type of knowledge that you're learning, that you feel that like the world is opening up. That's the kind of teaching that we all would love to, either have or be providing. And boy, that takes an awful long time.
Right.
So, coming out your first couple of years, how could you be masterful? It's really, really difficult.
Right. And so that's one of the things the Idealized Science Institute aims to address is like, let's say you get a job as a high school physics teacher and you are well intentioned and you really want to do a good job. Nonetheless, it's an incredibly challenging thing to do. And our goal is to provide your expertise essentially in digital form, and provide people with lessons and training on how to really foster discourse in the classroom, not just get through content. How do we use quick quizzes and these things to initiate dialogue in the classroom and to really lead to authentic experiences for students? And so, but maybe getting back to the article, let's give some facts. So like literally interpreted, who is teaching physics in the U.S.?
In general, not physicists, right? So that's fact number one. Fact number two that we have to keep in mind is not all physics courses are created equally. Every, university, every program, every quote academy that they have, they're going to have a different level of, all right, what is the focus on mathematics? What is the focus on education and content? And remember, these are just pieces of teaching well, especially in science. That nature of science, that's an important piece. The physicality of interacting with nature, that's an important piece. So how do you stack your chips? You can do a lot of these online courses now and become a physics teacher, and essentially all you're doing is math problems. How that would qualify you as a physics teacher, that's a tough one, but you could get through your courses just by doing simple equation manipulation and really never talk about the physical nature of the universe. You could say, well, numbers represent, everything in terms of matter and interactions, but that's not really what physics is about. I mean, certainly numbers are vital to what we do, but there is, and this article, along with almost every other good article, brings up this word, and that is the spirit. The spirit of interaction, the spirit of learning, the spirit of science. And that is often what we end up losing when we decontextualize, when we end up taking the physical parts, the experimental part, the experience out of it, and we're left with just numbers, without thought. It's just sanitized to the point where it doesn't.
I think the word. Well, there you go. I was gonna ask. Well, or I was gonna bring up that I think the word you use frequently there, sanitize, is like it captures exactly the problem, because these textbooks, even a good textbook, right? It is a sanitized version of history. It is a sanitized version of the content. Now, I'm not saying to learn mechanics we should all go back and read the Principia and everything that follows it. Now, you in your class do have students read sections of it, and I think that's incredibly important to read source materials when they're masterfully selected to weave in and complement everything else. but science is messy, and I don't think we capture that at all in the classroom. But again, all of these conversations could just bud in a million different interesting directions. But the idea of the article is pointing out that, okay, look, we don't have, when people say, why does reform fail? At the secondary level, at least, one of the things people always point to is we don't have the teachers that are prepared, right? We do not have teachers with the expertise, and first off, we don't pay teachers enough. And as you say all the time, teachers are respected. I put that in air quotes, not because we don't actually respect teachers, but what do we mean when we say respect? If I respect someone that I employ, I'm going to pay them more, right?
Let's just ask you, when you come out,
we don't pay teachers
when you come
more.
out after
Right.
all of these years of dedicating yourself to learning this field of physics or whatever, do you want to come out and say, I'm going to be a physics teacher? And the very first thing that people have to think about is, first of all, I have to pay back loans. How am I ever going to do this? I can't afford to be a teacher.
Right.
So, and it's
Right.
not like, I know that sometimes we try and think that all disciplines are created equal, but some, let's face it, are more difficult. And when you're, looking at the pool that you have to choose from, a lot of people in the physics community are going to say, I can't afford to be a teacher. I would like to be, but I can't afford it. And that's a reality.
That's the reality. That's the reality. And it's not even making, like, the comparative statements are always tricky because, but the data are just clear about who spends more time, who is obligated to spend more time on their bachelor's degree. And when I say time, actual hours put in outside of class. In physics, maybe the stat off the top of your head, but I think for physics and math and computer science, it's a factor of 2 or 3 outside of every hour in class more than other disciplines. And so that's just a fact. But so you get through all this, and the other thing is, because these are such difficult subjects, and because the outcome usually leads to a high-paying job if you're to go into industry, now you're asking the question, how can I get these motivated, talented people to turn down a starting salary of $150,000 at Google to come take a salary of $60,000 living in Boulder teaching math,
60,000,
teaching computer science.
60,000 is wonderful, right? But that's at Boulder.
Right.
Let's take it to some rural areas, and that salary is going to be half or a little bit more than that. That is really, really hard.
Right.
Right. I mean, really hard.
It's incredibly difficult, and so the only, I'm sure there are other organizations that do this out there, but the only organization that I know that just straight up pays more money to keep people in the field is the Simons Foundation. In New York, math teachers can apply, and if they demonstrate that they're motivated and they're going above and beyond, Jim Simmons, I always forget how you pronounce it, but they will just pay you like $20K more on top of your salary. And part of me thinks that that's the kind of thing that we need to really affect change. We say, why is there not change? I personally think that it's money. That's maybe not the most interesting thing to get into, so let's keep going through. That's kind of the obvious answer that everyone gives, but let's keep thinking about some of these issues. So they talk about the Every Student Succeeds Act, and it really wanted to address the No Child Left Behind Act and really the shortcomings of No Child Left Behind. Now, this is 2001, Bush era, legislation. Now, I remember hearing about it, even though I was very young. I remember hearing about it a lot when I was in elementary school and middle school. And the reason is I remember PSSAs. So in Pennsylvania, it was the PSSAs, which were eventually replaced by the Keystones. But I remember being stressed about standardized tests from a very young age. And so maybe you can shed a light on sort of what the No Child Left Behind Act intended to do and what it actually did. Since you were teaching from late 90s, early 2000s. So you were going through it when it came out.
Look, the No Child Left Behind Act, in general, will make most teachers cringe. Most have a negative feel for this particular act. And to be fair, it actually did a few positive things. In general, I would say the negatives far outweigh the positives, but one of the things was you literally need to make sure that each and every student is being thought of when you're teaching. One of the unfortunate consequences of this, and this is kind of like, this whole notion came in as like a business model that look, we have the educators, we've got academia, and they're in this ivory tower, but we live in the real world. And the real world, business rules. And so they were using these business ideology, this business methodology of, look, certain businesses should go out because they're not as effective as others. So what you end up having is you have schools that were already poor, that are already struggling, that already have severe issues, severe stresses on them. They're not going to do as well, and they're being judged by the standardized scores. And to be fair, it was about the change in the scores along with the absolute score. But those schools, many of them, were not doing well. And you have these affluent schools that were, as you would expect, doing well. You have more community support and so on. It turned out that some of the money from the poor schools was being pushed up to those more the schools that already had lots of money. The idea was, look, we'll get rid of these other schools. I don't know if they were exactly explicit about this, but if we get more of these better schools around, everyone will have a choice to go to one of these top schools. And in this idealized, like theoretical world, it almost made sense. Unless you were in a community that says, well, my school's got shut down. Now I got to try to attend a school way over there in a community that I'm not part of, that I don't feel like I fit in. I'm going to suddenly go there. And by the way, it might be an hour and a half away now. Gee, what could go wrong with this? Other than many students would just say, I'm not doing it. You shut down my school. You're telling me I could go over there. They don't want me over there. I don't want to go over there. I'm not going to school. So, of course, there's unintended consequences.
Right. It's crazy to me that, I mean, I had never thought of this until you said it, but the idea of something like this, something with a business model sort of mentality, taking from the poor and giving to the rich, it's something we see literally every day, every year in the U.S. This seems to be what happens in a capitalistic society, is we get these new programs. Sometimes they're just overtly to benefit the rich, right? There's things that we see that are like that. But sometimes it is well-intentioned, and then it always ends up somehow, the rich get richer and the poor struggle even more. And with education, it is crucial to lift everyone up and especially focus on those that are underserved. And again, this is why Idealized Science, the Institute, our goal is to start by focusing on those underserved communities and attempt to create things that are lowering the barrier to high quality physics education.
And let's be clear
I think
here
that it's more grassroots like this.
Just because you're in a more affluent district, often that doesn't mean that your teachers are necessarily any better or their methodology is better, because often they feel even more pressure just to make sure they're doing well on the test, and that's their focus. Nearly 99% of their focus is, look, it's not about understanding this, we need to get those scores. And so there's pressure all around. So the idealized science institute will be for everyone, but it'll probably help those that are disadvantaged more.
Right, and I don't mean to conflate having an underserved school with low quality education, because as I know, going to Freedom and having you as a teacher, we have a school that has no AC. It has not had a functioning pool for the swim team since I was in middle school, for some financial reason that I'm not aware of. There is no science budget, as you can attest. We use computers that are 10 years old and essentially, non-functional. And then every once in a while they get some $200 new machines that are also essentially non-functional. And yet I had the absolute best world-class physics education and have you to thank for that. That is absolutely possible in every single school in America and in the world if we have teachers like you that are extremely motivated to make a difference. So, it's
and let's just be clear. There's nothing special about me. I mean, it's not like I've created all this. Much of what we know has been known for a long time. it's about effort. And to be fair to Freedom, we've always been known as a community that does an amazing amount with very
Right.
little. Literally, the community prides themselves on that. That might be also a Pittsburgh thing. Like, I don't know anything about sports, but it's my understanding that the Steelers and the Pirates were always, they had less money,
Right.
but they had grit. You
Right.
know what I mean? And I think that there's that sense of, look, we don't have it, we're going to do it anyhow.
Yep.
And you got to admire it. You know what I mean?
Absolutely. I mean, it's the working
yeah.
class mentality that
Yeah.
honestly makes Pittsburgh a great city, in my opinion. It really is like valuable. And I think,
And the food. Don't forget about the food.
well, I think that's,
It'll kill you. It'll kill you.
Yeah,
but
it'll
it is
kill you
fantastic.
quickly, but it is good. Okay. But so, we have the No Child Left Behind Act. Lots of unintended consequences. In fact, more children were left behind, and we were leaving, poorer children behind, even though we were trying to address that. And I say we, the administrators at the time were trying to address that. And now we still see these issues with like standardized tests to get into college, right? Essentially being correlated with socioeconomic status. So it's still an ongoing issue that we're trying to address.
And let's be fair here. There will be some people that will argue that No Child Left Behind is a success. It depends on your perspective and how you're thinking about it. No Child Left Behind did elevate some of our lower scores. And so that was a positive.
If you take scores
literally
as
meant-
a metric of success, right?
Yeah. But if that was your objective, right,
Right.
then they could say this was successful.
And I
in
think
some
we'll have to
ways,
have
but-
obviously many other discussions about what is assessment and what is
Yeah.
success in education, and there's
course.
so many different axes along which that could be defined. But
Yes.
so it talks about how this new act really establishes the legal precedent for academies. That the goal at least was to remove barriers to entry to educate physicists again. Or physics educators, sorry. Again, though, it feels like a business model type initiative.
Doesn't it sound on the face of it like it's a good idea? Like Einstein. Everyone thinks Einstein is this uneducated person who comes along and revolutionizes physics. It's this mythology, right? So we've got these people out there that they know all of this stuff, and maybe they haven't gone to school for it, or they haven't been involved in academia, and we're just holding them back. So in the end, this mentality of you have to have the proper paperwork, a bureaucracy, where we're holding these people back. And so it kind of sounds like a good
Right.
idea.
On paper, again.
It's not.
Yeah.
It's not.
Right.
These people that, I talk to an awful lot of people that I realize are very bright people, and they've got some very interesting ideas. And then they'll start telling you about, well, we have carburetors that can get a car to go 300 miles to a gallon. And you think, well, if you know about the conservation of energy, you realize that's probably an untrue statement. So there is this a necessity for having some formalized education. But I want to point out also why it's not just a business model. Think about this. There are many other professions, and this is a whole nother discussion. Is teaching really a profession? Or is it like a job? Is it just something that you do? But think about how you become a lawyer. Think about how you become a doctor. Think about how you have actuary science out there. It's a test, right? You're going to end up being eventually certified by taking a test.
Right.
And so if you're saying, look, we just want education to be the same kind of professionalism as being a lawyer or being a doctor or something like that, we need a test, like the bar exam. That's what lawyers are studying for. If you're in actuary science, you're studying for the next certification. It is about passing those tests more than anything. So if you were to have that kind of mentality, you could see why this is attractive.
Yeah. I will push back a little bit and say, in the medical field, you do have to pass these tests. And I don't think that's, that's fine. But then you go to residency and you study under an absolute expert. So if we took that model in education and every teacher had to go study under someone like you who's had 30 years experience in a low SES district creating a world-class physics program, then the world would look very different, but we don't put the resources in. And so, but anyway, the goal of this legislation was to allow for these sorts of private academies, these teacher training academies to, reach more educators. But what really, to me at least from reading this article, what it seems to have done is sort of watered down the requirements, because they say here in Title II of the ESSA, it allows states to divert a portion of the federal education funding to the creation of these academies, but they have strict policies if they do that. They can't obligate faculty to hold advanced degrees or to have conducted academic research. They can't impose restrictions related to the number of course credits required as part of their degree program. I mean, at that point, like you said, you have someone that wants to teach, you take them to academy, they get certified in a month. It feels a lot like these, crypto academies where you are a certified trader of crypto after a month, it just feels like a serious
you have to
watering
give
down.
props to these authors. These authors, when they were writing some of this, they were just probably pulling their hair out, and yet they do such a balanced and beautiful job. And this is a really fun piece to read. I encourage everyone to read. It's only 5 or 6 pages. They do a wonderful job of, within those 6 pages, giving you a feel, trying to give you like the background. So I think they've done a really great job of allowing you to be a little bit infuriated at times, and also understanding, how do we solve this?
And so they close with, a section called leveraging the law, and some proposals on how you could actually use this legislation for good. And I really like the closing paragraph, especially as someone who's considered going into a national lab. Again, I want to teach. At the end of the day, I want to be a teacher. And I know you can be a teacher in many different forms. You can be a mentor in a company, and that can be a form of teaching. I want to be a formal teacher, either a professor or a teacher at a high school. But what they say is actually a little bit encouraging at the end, I think. It says, what would a collaboration between a physics department or national lab and a teacher preparation academy look like? And I think that's actually a great idea. If I was at a national lab and could have, and I know that the DOE funds things like this. They have teacher preparation academies where they will have teachers come and work at a national lab essentially for a summer and see what science really looks like on the ground. That can have an incredible impact then on the students' lives when the teachers go back and share that experience.
But does it? I mean, look, if you're teaching for 15 years and you were taught one way and you go away for a 6-week program, can you really change everything?
No, I agree.
I mean, every one of your lessons is structured a particular way. So, this is why it's so important to get, after the fact, trying to fix things is very difficult. What we need to do is we need to, in our everyday teaching, everyone just needs to say, all right, how do I take whatever I can do and move in this direction, right? And, imagine if you had that mass, and that's what we hope with the Idealized Science Institute. We hope to give some tools that you could say, oh, this is one piece that I could start off with. I don't have to change everything that I'm doing. I can. I have a video that I watched. I saw this. It looked like it worked. That's something that I feel comfortable I could do, and maybe that'll go well, and then I could try something different there. So incremental, small pieces.
That's what we're shooting to do, because at the end of the day, what was this article about? And again, just for, in case you were zoned out at the beginning, we're reading Valerie Otero and David Meltzer, Physics Today from 2017, entitled "The Past and Future of Physics Education Reform." And why are there so many barriers to change? And I think at the end of the day, people try to make these large structural changes, or they try to make legislative changes. But what we're trying to do is just on the ground. You're a physics teacher. You want to do better. How can you do better and a little bit better every single day, and let that compound over the decades that you're going to be teaching? That's what we're aiming to do, and we hope to address some of the issues in this article through the Idealized Science Institute.
And remember, as the authors point out, look 150 years ago, what were they saying? Well, try not to just speak directly at students and just load them up with facts that they're going to memorize. I mean, this is nothing new, right? Engage them in real physical activities. Allow them to understand the genesis of this knowledge, which we now call like the nature of science. How do we know, why we should feel that this is a competent, instructive piece that we've just done, or are we just going through the motion? So again, this is nothing is new here. We just keep cycling through, and we see it over and over again. The pendulum swings back and forth, and let's face it, a pendulum going back and forth is really the same thing as cycling. Right. So it's nothing new.
Right.
But
no, absolutely.
How do we encourage to take the pieces that we feel that have essentially been agreed upon for 150 years, how do we actually get those in the classroom in everyday lessons? That's really what
That's
we're
it.
after.
Yep. And I mean, we certainly didn't cover this, and I don't think the goal of the podcast is to cover every paper in excruciating detail, but rather give a little bit of use it as a base for discussion and encourage people then to go ahead and read it. I hope that we added some context to this one. And as we said at the beginning, we could talk for literally probably hours about each page. And this is a 5-page article in Physics Today, which is geared at a general, readership. So,
And it's an easy read. It's a fun read. I encourage everyone to go through it. It's really a nice piece.
Yep. All right. Well, Wargo, thank you for taking the time. It's always a pleasure. And we'll see everyone
Always
in
nice
the
talking
next
with you.
one.